Hey, what's up guys? Welcome back to the next video. So in this video we are going to discuss about how to print the numbers from 1 to up to n. Okay, so what is mean by prime number and how we can print the prime numbers between one range, like let us say from 1 to 100 or 1 to 200 or from 1 to 300. So these things we are going to discuss, but before going to the actual code, I just want to explain you something about prime number. Okay, so prime number is something, we know that a prime number is something which is divisible by 1 or by itself. Okay, so for example, let us take example 2. Okay, so 2 is divisible by 1, so divisible by 2 is divisible by 1, and also it is divisible by 2. So every number is divisible by itself, or else it can be divided by 1. So 1 can divide any number. Okay, so that is prime number. But in case of 4, if I take, okay, so let us say I will take example 4, and if I want to check the same rules, like whether it is divisible by, so 4 is divisible by 1, yes, it is divisible by 1, and whether it is divisible by 2, yes, 2 2s are 4, and also it is divisible by 4 itself. So you can see it is not only divisible by 1 and itself, it also divisible by some other number. So in such cases we can't say that as a prime number. Okay, so I can conclude that a prime number is something which is divisible by either 1, which is divisible by 1, and also it should be divisible by itself. Okay, so this is the main principle, and you might have seen a lot of algorithms and programs where they will be using the counter up to m by 2, or some people will be using sqrt, square root of up to number. Okay, so let us say number is n. So these kind of algorithms you might have seen already. Okay, so if you are not getting those things, and if you want to do this in a much better way and much simpler way, then you must see this video completely, guys. Okay, so I just wanted to tell you another thing, like 3 is a prime number, right? So how many factors does 3 has? 3 is having only how I can write 3. 1 into 3 I can write, this is the one factor. After that 3 into 1 is another factor. So this is for prime number. Another number you take just 5, example randomly. So how I can write 5? 1 into 5 I can write, or else I can write let us say 5 into 1. So that means every prime number will be having only 2 factors. Okay, so in loop I will be writing the same thing. I will be taking a counter and I will be updating the counter each and every time I found this particular factor. Okay, so if the counter is less than 1, then I will be concluding that this is a prime number, and if it is greater than 2, then I will be concluding that it's a prime number. If it is exactly 2, then I will be considering as it's a it's a prime number, and the other cases are non-prime number. Okay, so counter should be equal to 2 if I want to conclude it as prime number, and for any other counter value the number will not be equal to prime. So this, if you are not understanding, then it's okay, you'll understand whenever we see the code in VS Code. Okay, so that's it, guys. And you can take like if I take 4, this is not a prime number, right? So I will be having how many factors? 1 into 4 I can write, then 2 into 2 I can write, then 4 into 1 I can write. So you can see here there are 3 factors for 4. Okay, so that means the counter is not equal to 2, so that means it is not a prime number. So I'll be doing something like this. Okay, so let me just delete these things up to prime number, and let me just write the code in VS Code. Okay, so I'll just minimize this thing, and you can see I have already opened one file. Okay, so that's the name is given as problem 16. Okay, so that's it, guys, and now I will write the actual code over here. So alright, so public class and class name, all those things are there. I'll just write a main method over here. Okay, so public static void main, public static void main. Inside this I have to write string, after that argument. So this is our main method. Got it, guys? Yes. So I will be taking one number, let us say int n equal to, let me just take, I will take randomly, let us say 350. Okay, so int number equal to 0. I will take another variable which is whose name is number and it is initialized to 0, and after that I will make use of string here, guys. Okay, so string result equal to null. So I will use this null string because I want to print the array of numbers, so I have to make use of string here. Okay, so see how I will be concatenating, and those things I'll just show you guys. Okay, so I will take one for loop for int I equal to 1, and I should run this loop until and unless it will reach the number which I entered. That means I should be less than or equal to n. After that I need to increment this loop continuously. Okay, so that's it for the first loop. After that I will be using another loop, and here I will be initializing the counter. So note that I'm initializing the counter in the for loop itself because it will be updated every time. So once I get the prime number, then I have to reset it to 0. So that's why I'm writing like this. So int counter equal to 0. Don't worry, I will trace this program in front of you. I will make you understand completely. So int counter equal to 0 is the this is the counter, guys, which is actually deciding whether it's a prime or not. Okay, so after that, here I will be writing the important loop condition. Here I will take that number which is assigned initially to 0. Here you can see it is storing 0. Now I will assign it to I. So whatever number I want to check whether it's a prime number or not, I will take that, that is basically I. So I will assign it to number. After that, another condition I will write until and unless number is greater than or equal to 1. That means 0, I can't check whether it's a prime or not. So that's why until and unless number is greater than 1 and number minus minus, that means I'm starting from higher number. I want to reverse the loop here. So number, it will be starting from number equal to I. After that, number is greater than or equal to 1, it will check, and then it will execute the conditions, and after that it will decrement the number by 1. So here comes the logic, guys. Okay, so when do you say a number is completely divisible by another number? When its remainder is equal to 0. So I have to use that same condition here. So if I modulus number, okay, so I modulus number is equal to 0, if this is true, okay, so that means the number which I entered is completely divisible by itself. So itself, first one is itself condition. That means number divided by the again number I am doing. So I is also number and number is also number here. Okay, so just think of that, guys. Okay, so the number 2 divided by 2 I am doing, or if I take example of 2. Okay, so number divided by number is equal to 0. That means I have to increment the counter because it is one of the factor. Okay, so counter plus 1 I have to do, and I have missed u here. Okay, so counter plus 1 I have to do, and after that, if this after looping through all those things, that means the counter will be holding some value. Then I want to check whether counter is holding 2 or not. So if counter is equal to 2, so if the value of counter is equal to 2, then I can say that it's a prime number. So I will be appending it to the string. So strings variable is result. So result equal to, just see, guys, how I am concatenating. Result equal to result plus I have to give some white space here, otherwise it will throw an otherwise the number will be not distinguished to our I. So just see how I will be writing result equal to result plus I. Let us say I's value is 2, then okay, so result is 0. 0 plus 2 will be 2, and 2 plus this empty string will be 2 and blank space. Okay, so something like this. Let me just show you. I plus 2 it will happen. After that plus there is empty space inside this one, something like this. So its output will be, guys, okay, so this just I want to say output will be 2, and after that some space will be there. Okay, so if I concatenate another element, then it will be printed here. Let us say 3, again it will be having space. Again if I append another element, it will be printed here, again it will be having space. So that's why I have to give this space. Okay, so many students get confused why I'm giving space, so that's why I'm just explaining a little, guys, regarding that one. Okay, got it? Yes. So after completing all these for loops, okay, so first for loop and second for loop, here is the second for loop ending. So after that I just want to print. Okay, so I will write sysout system.out.println the prime numbers between, so between n, okay, so between 1, after that I will write, and here between 1 and n r. Okay, so something like this I will write, and at the end I will concatenate it to result. So I want to print the result ultimately. Okay, so this is how I can print. So let me just minimize these things. Okay, so everything is fine. I think I'll just open a new terminal over here. Okay, new terminal, and let me just run this code, guys. Okay, so Java C, and the file name is problem16.java. I'll just compile this one. Hope so. Yeah. So after that, Java problem 16 will just run, and here is the result, guys. Okay, so between 1 and 340 these are the prime numbers which are available. So 2 is a prime number, 3 is prime number, 5, 7, 11, 13, 17. So you can find each and every number which is displayed over here is a prime number. So I will just reduce this n value to, let us say I just want to find out the prime numbers between 1 and 10. Okay, so I'll just save this code again, compile it, and run it. So these are the prime numbers which are present between 1 and 10. So 2 is a prime number, 3 is prime number, 5 is prime number, and 7 is prime number. So the prime numbers between 1 and 10 are, okay, so here I could have given space. Okay, so after between I want space, and after, and also I want some space, so that the output will be more clear for viewers. Okay, so I'll just run this one. Now you can see the prime numbers between 1 and 10 are 2, 3, 5, 7. So like this you will be able to find out the prime numbers, guys. Now okay, so now comes the question of tracing this one. Okay, so I'll just copy this thing, guys. I'll just copy this for loop, these two for loops, and I'll just show you in the notepad itself. So I copied these things, and I will paste it over here. Okay, so let me just okay, so okay, no problem. I hope you are able to see. Okay, so see, first of all, let me just take the value of n is equal to 6. N is equal to 6. That means I want to find out the numbers which are present, prime numbers which are present between 1 and 6. So what are the numbers? 2 is one number, after that 3 is there, after that 5 is there. So these are the only prime numbers which are present between 1 and 6. I want to get them. Okay, so first of all, what I will be doing, n value I have given 6, and this is the output, expected output, guys. Okay, so let me just write output. Okay, so first when the loop starts, the n value will be equal to 6. Okay, so I equal to 1, I is less than or equal to 6, I plus plus. So int counter is holding here, counter is holding 0. So first initially it is 0. Okay, no problem, 0 is there. So for number equal to I, so here you just see, guys, for number equal to I, number was initially holding how much? Number is initially 0. Now number will be equal to, so I value is what, guys? I value is 1 from this one. Okay, so I value is 1, so I value becomes 1, and I want to run these things only if number is greater than or equal to 1. So we know that number, anyhow 1 is not a prime number, so number is greater than or equal to 1. 1 is greater than or equal to 1, it will check. So number will be replaced by 1 here. 1 is greater than or equal to 1. No, it is not greater than or equal to 1. Then it will come here. If counter is equal to 2, counter is not equal to 2, it's 0 right now. Okay, so 0, so that's why it will not execute these things also, and it will come again and it will make this I plus plus. That means now I is equal to how much, guys? I is equal to 2. So the again same thing will happen over here, and number is equal to I means here this will be replaced by 2, number equal to 2. So now number became 2, and here also it will replace by 2. So 2 is greater than or equal to 1. Yes, 2 is greater than 1, then it will come here. So I will be replaced by again 2. 2 divided by number is holding what, guys? Number is holding 2. So 2 divided by 2 will happen here. So that's why I said number divided by number is the first condition. 2 divided by 2 is equal to 0, of course. Then divide 2 by 2, the remainder is 0, then it will increment the counter. So now at this moment this 0 will change to 1. Okay, so after that it will close these things, come out of these things, and okay, so it will decrement the number by 1. So 2 number is holding previously 2, now it will hold 1. Again it will check the condition whether this 1 is greater than or equal to 1. Yes, 1 is equal to 1, that's why again it will come over here. So 2 divided by number, so number is holding now 1. So 2 by 1 is equal to 0. Yes, anything number divided by 1 will be equal to 0. So that's why counter will again increment to 2. So counter will be incremented. Now the loop has been completed, because if I decrement number by again 1, then it will become 0. So this 0 is greater than or equal to 1, false condition. So that's why it will not execute, and it will come out of this loop, and it will come over here if counter is equal to 2. So yes, counter is holding 2, then result will be equal to result plus I plus, that means result is holding result is holding 0. So 0 plus the number is 2, because I value is currently 2, guys. Okay, so I value is 2, and after that blank space, and 2 will be printed. So the same thing applies for 3 as well. So if I make it as 3, then again it will come over here. So this will be reset. Okay, so this will reset, that's why I have written inside this for loop, because I want to reset the counter whenever I take a new value. So it is necessary to write this counter inside the for loop. Okay, so after that, for number equal to, so now the number value is 3. Okay, so it will check again 3 is greater than 1. Yes, and it will replace this 1 by 3, and this is also 3 by 3. Okay, so counter will be incremented once. After that it will decrement whether now the number value become 2. Okay, so this will become 2 because I am decrementing, and again it will try to divide this 3 by 2. So 3 by 2 is equal to 0, no, false condition. Again it will decrement. So now this 2 will go to 1. 1 is greater than, yes, 1 is greater than or equal to 1, and 2 will be replaced by 1. 3 divided by 1 is equal to 0. Yes, it is equal to 0, and it will go to it will increment, and counter will be holding finally 2 over here. Okay, so that's how it will again concatenate that one. So now I have taken prime number cases. Let us take 4 as the input, guys. Okay, so let us take 4, and how it will be rejecting 4, let us see. So I is equal to 4, less than 6. Yes, everything is fine. Now counter is equal to 0, all set, and number is equal to how much? 4 in this case, and again number is greater than, that means 4 is greater than or equal to 1. Okay, so number is right now holding 4. Okay, so up to this everything fine, guys. Okay, fine. Okay, so 4 divided by 4, it will check. 4 divided by 4, yes, 4 divided by 4 is equal to 0. Counter is incremented to 1. Okay, so number will be decremented, and it will be holding now 3. So it will replace over here also. 3 is greater than 1. Yes, 3 is greater than 1, and it will replace here. 4 divided by 3 is equal to 0. No, it is not equal to 0. So that's why counter will not be incremented, and again it will decrement the number by 1. So it will become 2, and here also it will become 2 is greater than or equal to 1. After that this will be like 4 divided by 2 is equal to 0. Yes, this is the right condition, guys. Okay, so 4 divided by 2 equal to 0. So then counter will be incremented by 1 again, and now it become 2. So currently the value of number is 2, and it will be decremented by 1, and again it will come over here. Number is greater than or equal to 1. Yes, so 4 divided by 1 equal to 0. Yes, because any number divided by 1 will be equal to 0, and again it will increment the counter by 1. So here it will reject, because at the end it will compare whether counter is equal to 2. If it is if the counter value is equal to 2, then only it will be a prime number. If it is greater than 2 or less than 2, it will be not considered as a prime number. So this is the complete logic behind printing the numbers. Or if you want to just check whether a prime number or not, then you can use directly, guys. Okay, just give a counter, then divide that number by itself, and let's just write a loop like this. So it will be running reverse from number to the last value, that is 1. Okay, so if it is divided by, then you can just increment the counter, and at the end you have to just check whether counter is holding 2 or not. So I have shown you the code over here. So if you want to get this code, then of course it will be uploaded on our official website, then you can just check out, guys. In description I will be leaving the link for that one. So thank you, guys, thanks for watching. So yeah, that's it, guys. See you in the next one, and if you got any doubts in these things, then you can of course just ask in the comment box, and me or anyone of our friend, like the one who knows, he will explain you guys in the comment box. Most of the times our other viewers will be explaining, so kind of a mutual conversation will be happening. So that's it, guys, that's it. Thank you.